Greetings, this is Kevin with Math Practical. This is GIS Applications Lab 3. It's a climate lab. Let's just start up a new instance of ArcPro. Here we go. So for this week, we're going to be looking at some paleoclimatology data. So data that goes back 1,400 years based on tree rings and other things like that. So we'll start a new project catalog. I'm just going to call this Europe Climate 2 since I already made one, and make sure I put it in the right folder. Documents, GIS apps. There we go. Say OK, and I'll start up. And I tell you guys just to go get a world countries piece of data. I mean, most of us have that somewhere. You can get it from Natural Earth. If not, I'll link a zip shapefile down below this video. So here we are, our database. And let's see if we can new feature data set. We'll just call this climate data, no spaces, and we'll just go with WGS 84, just a good old XY coordinates. This is the full projections. Let's go up here to geographic coordinates, world, and then just plain WGS 84, WGS 72. There we go. Great. All right, and let that run. Just getting the project set up. And it should be in there. Yep, there we go. And then I'm going to go ahead and import some data into that guy, just the countries of the world. And I'm going to do feature class as a single, so I can rename it. So input, I'm going to search for it. So let's just take a look in folders, go up a couple. I'm pretty sure, no, how about in documents? There we go. All right, apps. And I know under my African aid one, I had some raw data, including some world countries. So there we go, countries all. And we're going to just call this countries and let it rip. And we'll take a look and see. So it does look like it's in there. And what's cool is you can right click and say add to new map, and it'll make a new map tab for you. There we go, countries of the world. I know that we're going to be working in Europe, so I'm going to zoom in to the continent over here, and then I'm just going to make my countries with no fill. No fill, and yeah, like a medium gray for the outline, something like that. We can always change it. I probably won't need this topographic base map. So there we go, that's our start. So I'll save the project, and now we got to go get some data. So in the instructions, what we're going to do is we're going to look at a paper where some researchers, Guyot et al., took pollen data, seafloor cores, ice cores, tree rings, and recreated a data set gridded over the top of Europe for 1,400 years. So let me go ahead and bring this over. So this is the article that they created from it, Growing Season Temperatures in Europe for 1,400 years. And they were looking at the spring growing seasons, so like April through September, spring and summer. And they went through, and if we take a look at one of their figures, so they have temperature proxies that recreated paleoclimate going back all these years, right? And they also have this data for us where we can download it on the NOAA site. So it makes it pretty handy. So if we go to data sets right here, paleoclimatology, and then data search, and then we just type in, or if you copied it and have it, Guyot, right? And then we'll go down and you'll have 3 of his articles in here. And the one we're looking for is this European 1,400-year spring-summer temperature reconstructions. Click on that and highlight it. And I don't use this download data right here. It just causes issues. If I scroll down on the page, you can see it right here. So original data and full metadata, you can download it as an XLS. So download that and save it into your folder for your project. And now I'm done with those, and let me bring it over. So this is what it looks like when you get it. So this is the entire data set, the lat and long, the year from 600 AD all the way to 2007, I believe. So a lot of data. Now, we can't bring this into ArcPro on its own. It's too big, and we also have to do some movement of the data around. It's not data intensive as some of our other projects, but there's still a few things we have to do. So we'll select here, Control A to select everything, Control C to copy it. I'm going to go to File, New, grab a new workbook. Oops, not open, new. There we go. blank workbook. And then with the first block highlighted, go to Paste Special, and then right down here I'm going to hit Transpose and OK. And that took care of it for us. So now we've got a header with each one of the years, and we've got our Latin long. So this is station ID underscore ID. This becomes long. This becomes lat. Don't need the standard error. We're not going to be evaluating that, so we can delete that. We don't need this year. All right, delete that. We are going to have to change these years. Well, actually we don't, because we're going to just hold on to the data just long enough to get some averages, right? So then we would go ahead and save it out, and then we're going to actually do some averages. And I have another version of it just so I don't have to bore you forever with it. So let me make this smaller, and this one right here too. And let's see if I can find the data that I had. Yep, so there we go. Let me bring that over. Okay, so what I did is I went and just made some columns all the way over on the right, and I got the average all. So for all the 1400 years, that's the average temperature. And these are anomalies above the 1961 to 1990 global average. All right, so these anomalies in centigrade above or below that. And then we went ahead and did a comparison of the 61 to 90, because that 30-year period is what we're considering the baseline of average temperature. And then we looked at the medieval warm period, and I just Googled around, found out like what years were the medieval warm period, went ahead and established those. Now years might be a little different depending on what you find with your research, but that's okay. Little ice age, industrial revolution, so the start date of the industrial revolution until present, and then last decade, so the last decade of the data set, which should show some significant warming. So what are we trying to do here? Well, we're trying to test how well they were able to reconstruct climate from climate proxies, right? So if we take a look at the average for everything for the whole 1400 years, how does that compare to the 30-year period? What should it look like when we make maps of this? Should it be warmer? Should it be cooler? What should the average between 61 and 90 look like when compared to 6190? Should be really close to 0, right? So this helps us gauge the accuracy of our data. And then medieval warm period should be warmer than today. Little ice age should be colder than that 61 to 90, so on and so forth, okay? Save this out as a CSV. That's important unless you've got the plugin inside of ArcPro. All right, so I can close all these out. Let's .save it. And let's go real quick to our folder. So I can go into here and grab my raw data, which is just that climate averages. I'm going to go ahead and copy that and just put it in my new European climate too, just because I've already practiced this, so hopefully I can have a video without too many mistakes. All right, so now my European climate has its raw data, and we can go back to ArcPro. So there we go. Now what we're going to do is we are going to add that XY data. So first I probably have to refresh over here my folders so that it shows up, right? And then let's take a look inside of there, raw data, and climate averages is in there. Great. All right, back to the map. And then we're going to go to add data, add XY point data. And this little tool will pop up, and then we're going to navigate to the folder that we have our CSV in. Super. And the X field is long, lat field is Y, and it's in WGS 84. And if we hit run, we should see our points. There we go. Now it actually put these guys into our geodatabase, but not in our featured data set. So that was a small mistake. I should have probably gone ahead and made sure that it ended up inside of the featured data set right there. I could fix it right now, but it doesn't matter too much, right? Because we're just going to use this data to create our surfaces. But if you want to do it correctly, you would navigate to here and then rename it, like what did I call it? Let me just check my instructions, make sure I'm getting everything right for you guys. Climate averages is what I called it. So if I go inside here and call it climate averages, I think there's missing something there. How about another A? There we go, climate averages. Super. Save that. And then I could rerun it again and it'll put it in the right place. Then I'm going to have 2 copies of it. There we go. I'm going to get rid of that first one. Okay, now it's in the right place. And it comes in with these little pins. It doesn't really much matter. But what we do want to do is right click on this guy and say zoom to layer. So now we've got all of our 125 points over Europe, and then we should, before we start running our spline tools or our Isarithmic tools, we definitely want to go ahead and project this data frame. So I'm going to go into my map, properties, coordinate systems, and go to projected, continental, Europe, and if we scroll down, there's an equal area. All right, and we'll do that for now. And it's got a little bit of a kick to it, right? So but if we check the center of it, it looks like it's at about 22, oh, maybe closer to 24, so we'll go back in it again, oops, back here, we'll right click and say copy and modify, and instead of having a central meridian of 10, we're going to put 24, and we're going to change this up here to mod so we know that it's modified. See if that straightens us out. Yep, there we go. All right. And for our layout and stuff, we don't need all these countries out here, so we can just go ahead and zoom to layer again on our dots, our points. There we go. And then we can go back into the map properties again and take a look at the clip layers and tell it custom extent, right? And then current visible extent. And then hit apply and hit OK. And now we have just these countries to watch when I zoom out. So it's gone ahead and cut everything out. So if we go ahead and zoom to layer again, and it's just masking that data. Now those countries are just for the background. They're not going to affect the data that we're doing. Okay. All right. So let me check my instructions, make sure we're doing everything properly. Yeah, it's good to save the project at this point. Okay, and then we can start doing what we want to do. So we want to create a bunch of raster surfaces that represent the temperature for those different time periods that we took the averages on. And we can experiment, and in the lecture I talk about what's the right tool for the kind of data. And so what kind of data is this? Well, it's gridded data. Before we projected it, it was in a perfect grid, and it's extrapolated data because it's from all of those different temperature proxies. So the right tool for this is the spline, but there's many of them. If we take a look in the analysis toolbar, look at under tools, and look under toolboxes, let's see here. Spatial Analysis Toolbox under Interpolation. If we dig down and find it, these are all the interpolators, if they're in here still. They've put them somewhere else. Okay, fine. If I just type in spline, I can find where it is. So there's the spline tool, and it looks like it's under Spatial Analysis. All right, so I'll go back one. I just wanted to show you guys everything. So Spatial Analysis Tools, and then Interpolation. There we go. So here are all the different interpolators. You've got inverse distance weighted, Kriging, natural neighbors, spline, spline with barriers, topo to raster, so on and so forth, trend. For our particular data set, the spline is the one. In the actual lab, I say you guys should experiment and do a run of the average of all the data on a number of these just to get a feel for what the different tools do and how the data looks. But in the end, you delete all those and you end up going with just spline. So we'll go ahead and get that. And climate averages are the points we want, and the long field is not what we're after. We're going to go with average all, and we're going to make sure that we put this inside of our geodatabase, inside of our feature data set. That's interesting. Why can't we, come on, work with me? Why does it not? Okay. Oh, it's a raster. Yep, so it can't go in the feature data set. Of course not. All right, so this is spline and AVG all. So this is for all 1400 years. I'll say okay. Now in the instructions, I say run one with regularized and then one run with tension, and you'll compare them and take a look, but we'll just cut to the chase. The regularized is the way to go, and then we'll hit run and see what we get. There we go. So that's what the temperature looked like for the whole 1400-year period across Europe. There's a couple things we can do to clean it up. I've noticed that to make it smoother, instead of bilinear, if you go with cubic, that smooths it out pretty well, right? The color scheme here isn't great. Let's see what the symbology looks like. We can just find something that represents above and below. And if we look at the data here, we've got temperatures below zero and temperatures above. So probably going with some kind of color scheme that is cool to hot, right? So like blue to red would make sense. If you scroll down, eventually you will find one. Oh, maybe you have to say show all to get all of them. I don't know why they hide some of them from you, but whatever. All right, yeah, what I'm looking for is right down here somewhere. Where is it? Dun, dun, dun. Here we go. And I use the stretched one so it gets them all. So there we go, and right now it's putting the hot temperature on the cool number, so I'm going to go under more, and I'm going to say reverse symbol order, and now we're getting closer to something, right? And we're going to end up turning off our climate average points, so you end up just looking at this. So, and if I look at the statistics, you can see that this guy has a minimum of 0.2 of a degree below the average, and a maximum of almost 0.2 above, so 0.18. So for over the course of the entire 1400 years, we're within 0.4 of the average, the 1961 to 1990 average. Okay. Now we're going to run that same tool on multiple different variables, right? So we're going to go back to analysis, go back to our spline. We can just open her up again and put our climate averages points in there. And this one is going to be 69 to 90. Oops. And once you've set it once, you should be able just to change it right here. So 61 to 90. Regularized, we'll run that one. This is the one I call the angry clown. You can kind of see it there. Remember, what should this look like? So we're comparing the average of 61 to 90 to the average of the paleoclimate data of 61 to 90. It should be close to zero. If we take a look in the symbology tab, right, we'll be able to look at the statistics and see what our total range is. So negative 4.8 or 0.48 to a positive 0.52. So this one is more of a degree difference, right? Now we don't need to mess with the colors and so forth right now. It'd be nice maybe to resample it to cubic. And we'll get around to normalizing all these things. So let's go ahead and then just keep running the old spline tool. And just get these done real fast. This can move pretty quick. So this one is going to be the medieval warm period. So this gets to be mid-warm. Regularized. It's all good. Run it. Very good. Tools again, spline again, and just keep getting them done. Right? Just making sure they're always being saved in your geodatabase. Now these are rasters, so they won't go in the feature data set. So little ice age. This is going to be ice age. Great. And we can run it again. Now see, it's telling us a warning this already exists, so you'd have to change it. That's why I like to go back to my tools and then reopen the tool each time. Uh-oh, I accidentally clicked and it told me that I was clicking on Saudi Arabia. All right, so let's open up spline again. We only have 6 of these to do, and we're almost done with all of them. Industrial Revolution. So this one ends up being in Rev, so Industrial Rev, and run. And we'll do one more. Spline, climate averages, and this one is the last decade. So this is the last decade of the data set that we have. And I need to change that. All right. So we've got all of our 6 runs. So here they are all over here, right? Now that last decade, that one's interesting. If we take a look at it and we take a look at its appearance and then symbology tab and then the symbolization or statistics, you can see that this one has a really high 2.85, so almost 3 degrees above the 90 or 61 to 90 average, and then a negative 0.35. So that's one that we'll have to kind of treat as an outlier. We won't be able to have it have an absolute normalized legend for it, but the other ones we can. So let's deal with the other ones first. So what we do is we look at all the rest first. And if you look at each one of these guys and look at its statistics, you'll need to make a list of its minimum and its maximum. So I just got a pad of paper and I just wrote it out, right? So I've got my Industrial Revolution, I've got my, turn that one off now, got my spline of my Ice Age, right? And there they all are. And it's got a negative 0.27 to a positive 0.46, and you just go through and get all the statistics for each one of them, and then circle on your list the one with the highest high and the lowest low, right? The one that's going to be a problem, as I was saying before, is going to be that last decade, because it got really warm in that last decade. So we'll treat that one as an outlier. But of these 5, turns out that the one that is the very lowest is going to be the medieval warm period. And when you're putting custom breaks inside of your symbolization here, it'll let you put a higher value than the highest value in your data, but it won't let you put a lower value than your lowest value in the data. So that's the key one. We want to find which one is the best and it is the lowest, and that's the medieval warm period. So that's kind of interesting though, right? That the medieval warm period has the lowest low, negative 0.58. And then our highest high is the 61 to 90 of 0.52. So you're looking basically to cover that, you need to cover the range of negative 0.6 to positive 0.6 to cover everything inside of your data. So what I say in the instructions is to go to the one with the lowest low, and that's the medieval warm period, change its value back to that color ramp that works good for temperature, right? And then we'll have to change this, reverse the symbol order, so the red is on top. I'm also going to change my sampling to cubic, right? There we go. And it turns out that I'm going to need at least 12, I believe, 12 different categories. And then I'm going to do equal interval just so it gets closer to what I'm looking for. Okay, cool. So now I can go through and I'm going to have to make, what I want to do is make 0.1 class breaks. I can also change my symbology just for go down to 2 decimal places for my labels, and that'll just make it easier to work with. And then I'm just going to start down here at my negatives down low. And this one's going to need to be negative 0.6, right? And hit enter. And then the next one would have to, and see, it's telling me it won't let me go below that, but that's okay because I can change it over here. So I can go under my label and change what it's going to look like. So it's going to be from 0.59 up to negative 0.6. Right? I think I got that right. And that's just going to change the look of the label, and then I can just work through the rest of one. So then this one would be a 0.5, negative 0.4, so on and so forth. And I just work through it until I have them all figured out. Now I can go through all this, but it's basically the same thing over and over again. This one would be a negative 0.3, right? And I've already done this once, so it's just easier for me to pull it up. So let me go ahead and do that. This is the first one that I ran yesterday. Now your numbers might be slightly different, right? Because remember, you figured out what your medieval warm period was going to be and got the average from that. You figured out what your little ice age was going to be, and so forth, right? All right, so that's my spline fixed up. But then here's my medieval warm period set up over it, right? So there's my medieval warm period, and I've got values from a negative 0.5 to negative 0.4, negative 0.3, all the way up to 0 in the middle. And then, so that's from kind of a white down to blue, and then going from white in the middle all the way up to red to the hottest zone. And in this particular case, though, if we look at the medieval warm period, if we look at the statistics, there's nothing in the top couple of classes because our highest number is 0.44, but that's okay. What we're trying to do is make sure that each one of these things is easily comparable, right? So if I were to compare the medieval warm period to my spline of the Ice Age, then you can see it has the same exact legend, but you can see, as we would expect, it looks colder than our average because it was a little Ice Age. So especially down around European continent, Spain, France, Italy, colder, but there is kind of some strange anomalies. So up here, Novaya Zemlya, and in the Scandinavian countries, we had some warm temperatures. Now, is that right? Well, as we look at all of our different surfaces, you start to see that maybe there's some problem with the data that's up here. If we, just turn on our points again, it's possible that there is some anomalies going with the reconstructions up here, right? But that's okay. That's what we're doing is we're, giving this data once over to make sure that they got the paleoclimate data correct, right? And we can look at the Industrial Revolution over the top of that. Slightly warmer, but not too much if we look at its statistics, right? Actually, we have to click on it to get its statistics to show, and then more, show statistics. There we go. Really close to 0, pretty centered around 0, less than 1/10 of a degree above and below. So how do we tell people what is above and below? Well, one way to do it would be to have a contour line that represents 0, and that works out pretty well. So let me go ahead and show you how I would do that. So if I wanted to set up a contour line of 0 just for the spline of the Industrial Revolution, then I would go to my analysis, and then tools over here, and then contour, and contour spatial analysis or 3D, and then I'm going to put in the raster of my Industrial Revolution, and then my contour interval. Now, if we put a contour interval that is greater than all of our data combined, and then we have a base contour that is 0, then we'll just get one contour line on 0. So that's what we're going to do. I'm just going to pick a number 5. I know that none of my data in this particular raster goes above 5. But definitely make sure you put it into your geodatabase and into the actual feature data set. So instead of the last decade contour, this is the Industrial Rev, right? Say save, and then we'll run it. And there we go, it's finished, and it came in as a green line. That doesn't work too well, but what about if I go ahead and make it a dotted line, take a look at its properties, change its color to something dark so it shows up, and hit apply. There we go. All right, so what have we done here? We're showing the break line between these two. So if I go back to Industrial Revolution, back to my symbology, we've got a break line that is 0. So right at the 0 line, this is where it matches. It's right on 0 from the 61 to 90 average. So really, really close, which is interesting because we would kind of expect the Industrial Revolution to show some warming. There is a little bit more up in Scandinavia, again, pointing to the possibility that these particular data points have a slight error or are less robust than the rest of the data set, right? So I ask you to make these 6 maps, to make a contour line that represents 0 on each one of your maps, just as I've shown here. I did have to, though, like I was saying, change the spline of the last decade, turn off the Industrial Revolution contour and turn on its last decade contour. And you can see here that the last decade, especially up in the Scandinavian areas, they had a lot of warming. And that kind of makes sense with climate change. They're saying that the Arctic is warming much faster than the lower latitudes. So up here in the high latitudes, you see more warming, but certainly they had a bit of a slightly colder than average period over the last decade of the data set, right? This one I ended up having to make a different break in the classifications, and that was because it's not showing that one because I wasn't having it shown. I went with 0.25 on this break, just because I had such a large range in my data from negative 0.35 all the way up to 2.85. So up here in this corner, really, really hot. And if you guys know anything about Novaya Zemlya, this is a very cold Arctic island off the coast of northern Russia, where they have a lot of like secret army, military, navy bases and stuff. But this is a place that's quite chilly. But in the last decade, it's seen almost 3 degrees of temperature increase compared to the 61 to 1990 data set. So I want you to do layouts for all these. Let me show you what one of my final layouts looks like. I have to navigate again to, where do I have this? Oh, I know, last year, workspace. And just put on your layout all the normal things, but the nice thing is that you'll have one legend for your first 5 maps, and then for your 6th map of the last decade you need to make a new legend. And then I ask you guys to go ahead and make a one map of the European countries that you're representing here as with labels for them, so you don't have to label the individual countries on all your maps. So here we go. Average temperature anomalies in Europe from 61 to 1990 compared to the global baseline for the spring-summer temperature of 61 to 90. And this should be fairly close to zeroed out. However, you can tell by comparing this that there's, the data is, slightly off, not too much. These are the 0 lines, so you don't have too much below, and you've got a number going above, but not too far. A little bit of a duck egg over here might be a problem with that one particular data point. Definitely call out that you modified your projection, get your name on the thing, and overall, you'll make 7 maps for this lab, and I think you'll learn something about how we look at paleoclimate data and how it's created. All right, if you enjoyed this video, please give it a like, subscribe to the channel, and we'll see you next time.